In this video, we'll look at the definition of a polygon, what we call different parts, and how we can label the polygon as regular or irregular, concave or convex, if the polygon is equilateral or equiangular. So the parts of a polygon are named on the quadrilateral below. We see that there are 1, 2, 3, 4 vertices. We call one of those a vertex. There are also 1, 2, 3, 4 sides. That's just like we were looking at sides of angles. That's a line segment that connects two of the vertices. There's also this idea of a diagonal. And a diagonal is a line connecting two non-adjacent vertices. So here is not a diagonal, but this would work. Another diagonal in this diagram would be a line connecting these. They are non-adjacent vertices. The definition of a regular polygon: all sides are congruent and all angles are congruent. That means that the side lengths and the angles are the same. A polygon is convex if all of its diagonals lie in the interior of the polygon. And a polygon is concave if all or part of at least one diagonal lies outside the polygon. So here are three quick examples. This polygon on the left is a regular polygon, meaning that all four of the side lengths are the same and all four of the angles are the same. This one is considered convex because the diagonals stay inside the figure. This middle one is irregular because the angles are not all the same. We have two swoops in this corner and a single swoop in that corner, indicating they are different angles. Even though the side lengths are the same, all the conditions are not met, so it's irregular. It's convex because the diagonals remain inside the polygon. Also, we see this one on the right, where the distances are going to be different because we see 1, 2 hash marks and 3 hash marks, as well as the 90-degree angles and these two being the same. Definitely irregular. We only have to spot a single diagonal, which is this red line here, that exists outside of the polygon for this to be considered concave. Here's what we name some different polygons, with the number of sides being on the left here and the name of the polygon here. If we don't know how many sides, we just know there's n, or some variable number of sides, we call that an n-gon. And if we haven't mentioned it so far, we should, that a polygon has to be a closed figure. So if you have 3 sides, you can't have 3 sides like this. That's not a polygon. That's why the only choice is a triangle. If a polygon is equilateral, then all sides are congruent. If a polygon is equiangular, then all angles are congruent. And remember that a regular polygon meets both of those criteria. So let's look at some of these in example 1 and classify them. Yes, this is a polygon. It's a pentagon, having 5 sides. Number 2, we can count up the sides. There's 7 of them, so it's a heptagon. Yes, it's a polygon. Number 3 is not a polygon. You have to have straight sides, so this curve here is the reason why it doesn't work. For number 4, the side lengths are different and the angles are different, so we call this an irregular polygon. Number 5, all of the side lengths are the same, all of the angles are the same, so it's both equilateral and equiangular, which means it's regular also. And number 6, we see that the angles are all the same, meaning it's equiangular, but the side lengths are not, so we would call this irregular. To figure out if it's concave or convex, we're going to look at the diagonals. All of the diagonals are in the interior here, so this one is considered convex. There are no diagonals in number 5 because you cannot draw a line from one vertex to a non-adjacent vertex. We'll just call this one convex. And lastly, we can kind of see how this one caves in here. If you were to draw the diagonal from these two vertices, it's outside the figure, so we will call that one concave.